From this video, we shall learn the procedure of solving the system of linear equation by Jacobi method. It is also called as an Jacobi iteration method. How to solve the system of linear equation by using Jacobi method. Like the video, subscribe to the channel, share this video link with your friends, gain the knowledge and rule the world. Apply Jacobi method to solve the system of equation a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3, in which the diagonal coefficients are not zero and large as compared to other coefficients. In such cases, the system is called diagonal dominant system. So this is the system of equation which has been given. So we can see there are three equations and you need to check that all of these three equations are the diagonal coefficients, whatever is there, those diagonal coefficients should not be 0. That is, in the first equation a1 should not be equal to 0. In the second equation b2 should not be equal to 0. In the third equation c3 should not be equal to 0. And those diagonal coefficients are large as compared to other coefficients. That means a1 should be greater than b1 and a1 should be greater than c1. And in the second equation b2 should be greater than a2 and b2 should be greater than c2. In the third equation c3 should be greater than a3 and c3 should be greater than b3. Then such a kind of a system of equations is called as a diagonal dominant system. To apply Jacobi method, we need to first check that whatever the system of equation has been given, that system of equation is diagonal dominant system. If it is a diagonal dominant system, then only we can apply the Jacobi method. Consider this set of system of equation as 1. So this is the system which we have been considering as a diagonal dominant system of equation, and to find the value of x, y and z, the above equations can be written as x is equal to 1 divided by a1 into d1 minus b1y minus c1z. How we get this particular equation? So consider a1x and take the other terms on the other side. That means a1x is equal to d1 minus b1y minus c1z. So therefore x can be done as 1 divided by a1 into d1 minus b1y minus c1z. Similarly, consider the second equation. So in that one we need to find for y. For that purpose we can write b2y is equal to d2 minus a2x minus c3z. Now since we want y, we can write y is equal to 1 divided by b2 into d2 minus a2x minus c2z. Then consider the third equation, a3x b3y c3z is equal to d3. So since we need to find the value of z, consider c3z on one side and the rest of the terms on the other side. So therefore we can write c3z is equal to d3 minus a3x minus b3y. Since we want z, we can write z is equal to 1 divided by c3 into d3 minus a3x minus b3y. And consider this system of equation as 2. Means this set of system of equation as 2. Consider the second set of equation 2, and by considering this one, we start with the initial values x0, y0 and z0. So these initial values will be given in the question. If it has been not given in the question, you need to consider the x0, y0 and z0 as 0 and consider 0, 0, 0 for x, y and z, and those are x0, y0 and z0. If it has been given in the question, consider those values as x0, y0 and z0. Those are the initial values. Substituting these initial values on the right hand side of equation 2, there is a system of equation which has been present here. You can see on the above, that is a system of equation 2. On the right hand side, you need to substitute these values and we get the first approximation, that will be x1, y1 and z1. Wherever y, z and x are there, you need to substitute as y0, z0 and x0. That means x should be replaced with x0, y should be replaced with y0 and z should be replaced with z0 on the right hand side of a system of equation 2. Then we get the first approximation, those will be x1, y1 and z1. So first, x1 is equal to 1 divided by a1 into d1 minus b1 y0 minus c1 z0. That is, we have just substituted y as y0 and z as z0. The next, y1 is equal to 1 divided by b2 into d2 minus a2 x0 minus c2 z0. X has been replaced with x0 and z has been replaced with z0. Those are the initial values. Then now z1 is equal to 1 divided by c3 into d3 minus a3 x0 minus b3 y0. That is, x has been replaced with x0 and b has been replaced with y has been replaced with y0. That is, substituting x0, y0, z0 in the right hand side of a system of equation 2, where x, y and z will be there, those has to be substituted with x0, y0 and z0. We get the first iteration, those are x1, y1 and z1. Now we shall move on to the second iteration. Just now we have calculated the values x1, y1 and z1. Substituting x1, y1, z1 values on the right hand side of a system of equation 2, we get the second approximation x2, y2, z2. It is also called as a second iterates. That means in the place of x, y, z of system of linear equation 2, on the right hand side, substitute them with x1, y1, z1. Therefore, what we get? x2 is equal to 1 divided by a1 into d1 minus b1 y1 minus c1 z1. That is, just we have replaced y with y1 and z with z1. The next, y2 is equal to 1 divided by b2 into d2 minus a2 x1 minus c2 z1. The next, consider the third equation which is present in the system of linear equation 2. So now z2 will be equal to 1 divided by c3 into d3 minus a3 x1 minus b3 y1. That is, just we have replaced x, y, z with x1, y1, z1 values. We get the second approximation, that is x2, y2 and z2. Just now we have calculated x2, y2 and z2. This process has to be repeated until we get desired order of approximation of the roots, or the difference between two consecutive approximation is negligible. That means you need to calculate x3, y3, z3, then x4, y4, z4, x5, y5, z5. Like this, the process has to be repeated until we get desired order of approximation of the roots, or the difference between two consecutive approximation is negligible for the given system of linear equation 1. This method of solving a system of equation is called Jacobi method. It is also called as a Jacobi iteration method. It is also called as a Jacobi iteration method. When we need to stop, when the desired order of approximation of the roots, we get the answer, or the difference between two consecutive approximations is negligible. That means x3, x4, y3, y4, z3, z4, or x5, x6, y5, y6, z5, z6, those values are nearly same. That means the consecutive approximation is negligible. They are almost same. At that point you need to stop, and whatever the answer we get there, that will be the solution for a given system of equation by using Jacobi method. It is also called as a Jacobi iteration method. Like the video, subscribe to the channel, share this video link with your friends, gain the knowledge and rule the world.